This problem is for you folks to try. Just a couple of notes before you get started. It involves cotangent, so that's actually 2 periods of cotangent. So it's up to you. You can do this the same way that we do things for sine, cosine, secant, and cosecant. Find all solutions in one rotation around the unit circle, and then add a multiple of 2 pi. I kind of think it makes more sense to just work with 1 period, which would be from 0 to pi, add a multiple of pi to that so that you would have all solutions first, and then just go back and list the ones that happen to be between 0 and 2 pi. The reason I prefer that is it allows me to be a little bit more concise in how I phrase my answers, and also if I ever have a situation where I'm just asked to find all solutions, I haven't done this extra work of finding all the solutions from 0 to 2 pi because it's really not necessary. I just need to work in 1 period. Okay. The other thing I'll point out is that that involves cotangent. Once you've isolated it, you have cotangent equals this number. If you prefer to work with tangent, you can rewrite that as tangent equals the reciprocal of that number. Either way is correct. Go ahead and pause the video and work this one out. All right, first thing I want to do is isolate that trig function. So 5 cotangent of x equals 10. Cotangent of x equals 10/5, or 2. Now, I prefer to write things in terms of sine, cosine, or tangent, because those are the 3 I'm most familiar with. So I'm going to just rewrite this as tangent of x equals 1/2. Okay. Now, when I see 1/2, at first glance I might say, oh, this is going to be one of my special angles, because 1/2 is familiar. But 1/2 is familiar because it shows up as the sine or the cosine of 30 degrees and 60 degrees. If I take a look at my 30, 60, 90 triangle, if I'm looking at tangents, tangent of 30 is 1 over root 3. Tangent of 60 is root 3 over 1. The 2 doesn't show up when I'm calculating tangent. And if I look at my 45, 45, 90, tangent is just 1. So even though that's a number I recognize, I don't recognize it in this context. Okay. So I'm going to just find my solutions in 1 period of tangent. And again, because I'm not graphing this, I don't need to start at an asymptote. I'm going to start where I'm going to ultimately want to start in answering part A. So 1 period would go from 0 to pi. That's quadrants 1 or 2. That's positive, so we're in quadrant 1. So there's my x. That means it's an acute angle. It's an acute angle. It's not one of my nice ones. It's arctan of 1/2. That's it. Then all solutions, which is going to be my answer to part B, is arctan of 1/2 plus pi n, where n is an integer. Notice I can add pi once. That's going to give me a solution here in quadrant 3, which is the other quadrant where tangent is positive. If I add pi again, I've rotated beyond, I've rotated back to something that's coterminal with this. Okay. And if I keep adding pi, I'm just bouncing back and forth between a solution in quadrant 1 and one in quadrant 3. For part A, solutions between 0 and 2 pi, this was our first one. If I add pi once, I'm going to get this solution in quadrant 3. So that would be arctan of 1/2 plus pi. Doesn't matter what order you write the addition in, pi plus arctan of 1/2 would be fine. Okay. But I don't want to add pi a second time because then I would have rotated past 2 pi. So here are my answers. I just answered part B first this time.